All right. We've been studying exponents, and so I'm going to go through some example using the rules that we've been studying. So for instance, here we have an exponent on the outside. Now, this 4 would go to both the coefficient here and the power here, right? And when you have an exponent on the outside as well as the inside, you would multiply these. Now, this can get confusing because the 2 here only goes with my base here, right? It doesn't go with the coefficient. But when it's on the outside of a parentheses, it goes to both the coefficient and the power here. All right. Here we see expanded form, so there are 2 x's on the inside, right? And there are 4 sets of these, right? So coefficients you just treat as regular. You're going to multiply all those 3's, right? And then you can count how many x's are there. So 3 to the 4th is 81, and we have 8 x's, so that's x to the 8. All right. Now here we have a negative exponent, right? So if I multiply this, I would get x to the negative 6, right? But if I want to write that with a positive exponent, that would be 1 over x to the 6. All right. Why can we not subtract the exponents as a shortcut in this expression? Right? So here we see the expanded form, right? 2 to the 5th comes out to be 32. 3 cubed is 27. The answer to this is the bases are not the same, so nothing cancels, right? But you could write this as 2 over. So you could write this as 2 to the 5th as 32 over 27. That's when you evaluate it, right? Or you can leave it as powers here. All right. Here we're asking which one is greater, right? Now, 4 to the negative 2, I could write as 1 over 4 squared, so that's 1/16, right? Here, that negative exponent will go in the denominator, right? 5 cubed is 125. Anything divided by itself is 1. Now, if we added the exponents, 3 plus negative 3 is 0. 5 and 0 is also 1. So 2 different ways you could get that answer there, right? 1 is greater than 1/16. Likewise, here we have 2 to the negative 2, right? And then 3 to the negative 3 to the negative 2, right? We've seen 2 to the negative 2 before. That's 1/4, right? Here you would multiply the exponents. Negative times a negative is a positive. 3 to the 6. I don't know what 3 to the 6 is, but I'm confident that's more than 1/4. So this would be the greater than symbol there. All right. So if we're multiplying with same bases here, we're going to add the exponents. If we're dividing, we're going to subtract. If you see the parentheses, you're going to multiply, right? Here you could factor out the exponent and multiply the 7 to 3. You get 21 to the 5th then. All right, we're going to do 2 more problems. These are a little bit harder here, right? I could, when in doubt, expand it out. You would see that's a lot, right? Keep in mind, coefficients you just treat as regular here. So 3 times 4 is 12. Here, that power on the outside, right? We explained earlier in the video that this would also go to the 2. So you get 2 to the 3rd is 8. If you're multiplying, you're adding exponents. You could always think of this as y to the 1. So 1 plus 10, you get y to the 11th. And here we would be, on the bottom, we would be multiplying exponents. So 5 times 3 is the 15, right? Now, coefficients treat like regular numbers. I'm going to reduce 12 over 8, so I get 3/2. With the exponent of 11 and 15, we're going to subtract that. We get a negative exponent, which means I should express this as 3 over 2 times y to the 4th, right? All right, last one here. We have some negative exponents, right? So you should, whenever you see a negative exponent, you should rewrite it where this y to the negative 2 is going to be on top. I make it positive. The x to the negative 2 is going to be on bottom. I would make it positive. Then we can add those exponents, right? And with that coefficient, we can reduce that. So this would be our final answer here. So these were just kind of a few examples using those properties. Feel free to rewatch those. And today's assignment is going to deal with problems and exponents and using the properties that we've learned.